So now we are discussing representation of force in terms of I, J and K cap. So that means what? So if this is the force and this force can be represented in three-dimensional coordinate systems. Three-dimensional coordinate system is what? This is the three-dimensional coordinate system, Cartesian coordinate system. This is the origin, this is x-axis, this is y-axis, and this is the z-axis. And this force is your OP is the force vector. And from this, see, try to understand here, I am drawing a perpendicular to the xy plane, and this perpendicular intersect xy plane at Q point. So from Q point, if I draw a normal at x axis to the x axis, this is your A point, and from Q point if I draw a normal to the y axis, then this point is your B point. Same way, from the P point if I draw the normal the z axis, this point is your C point. All these angles are 90 degree. All these angles are 90 degree. This OA I am writing here fx. This OB I am writing here what? Fy. This OB I am writing here Fy. And same way, this OC I am writing here Fz. Okay. So along x-axis, if we consider the unit vector is I cap, along y-axis the unit vector is j cap, and along z-axis the unit vector is k cap. So force can be represented by this way: fx I cap plus fy j cap plus fz k cap. Okay, this way the force is represented. Okay, so how you can represent it this way? So see here, try to understand how you can prove this one. So see, from O to A, this is a vector if I consider. From here to here, if I consider another vector, and from Q to P, I am considered this vector. So see, if I consider the quadrilateral OAQP, so from here I can write, if I apply the polygon law, see here, OA vector plus AQ vector plus QP vector is equal to OB. So okay, step by step I am writing OA vector plus AQ vector and QP vector. This is equal to what? See, OP vector, because OP is in opposite sense. So OP vector. So OA vector is equal to what? Magnitude of OA is fx and direction is what? I cap, because vector can be represented magnitude into direction. Same way, this is your AQ is equal to, see, AQ is equal to OB, right? AQ and OB both are parallel to each other. So I can write here as OB is equal to Fy. So AQ I can write here Fy. So see, Fy j cap I can write plus QP and OC both are parallel to each other and they are equal to each other. So I can write here if Z k cap is equal to OP. OP vector means what? F vector. So this is the representation of force vector in terms of I cap, j cap and k cap. Okay, so this is the representations now. So we can express any vector like this way. Now next one is what? Next one is your product of the two vectors. Already we have discussed addition of the vectors, subtraction of the vectors. Now here we are discussing what? Product of the vectors. So product of vectors. So now we are discussing product of vectors. So now I am considering two vectors. Product of two vectors. What is the product of the two vectors? That is what? See, if I consider two vectors like A vector and B vector, right? And they are making angle theta. Theta is the angle between them. So product of the two vectors product is two types. One is dot product, okay, and another one is your cross product. Dot product means what? So dot product means what? If you multiply these two vectors, then you are getting scalar quantity. And cross product means what? If you multiply these two vectors, you are getting what? You are getting the vector quantity. Okay, so this is the product of. Now at first I am discussing the what? Dot product. So what is the dot product? So see, A and B. So the dot product formula is your A dot B, that is equal to magnitude of A vector into magnitude of B vector into cosine theta. This is from your class 11 syllabus also. So I am not going into the details because here the application of the dot product and cross product is in your syllabus. Okay, many numerical problems in your syllabus. So here just I am giving the brief idea. So see, if I consider, I am considering A vector as A1 I cap plus A2 j cap plus A3 k cap. Okay, and B vector is equal to B1 I cap plus B2 j cap plus B3 k cap. Now if you want to take the product of these two vectors, then what you will do? So A dot B is equal to what? A dot B means A1 I cap plus A2 j cap plus A3 k cap dot B means B1 I cap plus B2 j cap plus B3 k cap. Okay, so this is your A dot B vector. Now here what is this A dot B vector? Means A dot B, that is equal to C A1 B1. I can easily write here A1 B1. Okay, detailed here if I do I dot I plus A1 B2 I dot J plus A1 B3 I dot K, right, plus A2 B1 what? J dot I plus A2 B2 J dot J plus A2 B3 what? J dot K. Okay, A2 B3, and last line is what? A3 B1 K dot I, A3 B1 K dot I, then plus A3 B2 K dot J plus A3 B3 K dot K. Okay, so see how you can find out this value I dot I dot J. So see here I dot I, that means what? If you consider the three-dimensional coordinate system, so this is your x-axis, this is y-axis, and this is your z-axis. So along x-axis this is I cap, along y-axis this is j cap, and along z-axis this is the k cap. Okay, so I dot I means what? I dot I, these are two equal vector and this is the unit vector. So that is what? Magnitude of I into magnitude of I into cos 0 degree, because both are equal vector. So you are getting what? One unit vector magnitude, one unit vector magnitude, and cos 0 means also 1. So similar way you are getting J dot J is equal to K dot K is equal to what? 1. But what is for I dot J? See, I dot J and J dot I both are equal. This is called the commutative principle. Okay, commutative law of the dot product. See here, A dot B is equal to magnitude of A, magnitude of B cos theta. If you consider B dot A means what? Magnitude of B, magnitude of A cos theta remain same. Okay, it remains same. So this becomes what? 0. Why? So if I consider I dot J into cos 90 degrees. So see, I vector and J vector, x axis and y axis, angle between them is what? 90 degree each other. Okay. So in this situation you are getting this way. So see here, if you consider, so that is what A dot B is equal to, try to understand, I dot j is equal to, this is equal to your 0, I magnitude of I magnitude of j cos 90, this is equal to what, 0. So same way j dot k also you are getting j dot k and k dot j. J dot k means what, this is j, this is k, they are making angle 90 degree, so it is again 0 because cos 90 is equal to 0. So same way I dot k is equal to k dot I remains 0. Okay, so unequal vectors dot product is equal to 0 and equal vectors dot product is equal to 1, unit vector C. So see here, I am getting a1 b1, I dot I means what, 1, plus here I dot j, this is 0, here I dot k, this is again 0, this is j dot I, this is again 0. So here I am writing j dot I, this is again 0, this is j dot j, this becomes your a2 b2, plus this is your j dot k, again it is 0, plus k dot I, this is again 0, k dot j, this is again 0, and this is a3 b3 is this one. So here a1 b1 you are getting plus a2 b2 plus a3 b3. So a dot b is equal to this, a dot b is equal to a1 b1 plus a2 b2 plus a3 b3. Okay, understood? So this is the what, this is the dot product. Okay, next we are considering the cross, this is the product, so dot product is over. Next we are considering what, next we are considering the cross product. Okay, so next we are considering the cross product. So see here, what is the cross product of the two vectors, that is so see, in the case of cross product, if we consider the cross product, so in case of cross product, what I am drawing, so see, this is A, this is B vector, and they are making angle what, theta, right? And see, they have this plane. Okay, they consist this plane. Now what is the cross product, that is what, so if you want to do A cross B, right, A cross B, that is equal to magnitude of A magnitude of B into sine theta into n cap. This n cap means what, A vector B vector, so n cap is, these directions is your n cap, and this giving you a vector quantity. Why? Here this is the magnitude part and this is the direction. Direction is which direction? Perpendicular. The direction, I mean C vector direction is which direction? Perpendicular to both the vector A vector and B vector as well as the plane of these two vectors. Okay, so this C vectors is like that way. So now this is n cap, and why C vector I have drawn along these directions, I can draw this direction. Why I have not drawn downward direction? Why I have drawn this upward direction? Because in this situation you have to know what is that, the right hand corkscrew rule. So if you apply, so try to understand, if I consider the screw here, this is the screw, and if you rotate the screw left to right direction, then this is the right hand screw, so it will moving upward direction. So that means what, try to understand. So this is your, so for example, this is A vector, this is B vector. So that means what, suppose for example this is A vector and this is what, B vector. Okay, this black color is your B vector, this is A vector. So A, B, A cross B means what, if you rotate A vector to the B vectors, if you rotate A vector to the B vector, so you are moving left to right direction. A vector to B vector, so you are moving left to right direction. So if left to right direction, that means what, if you move the screw left to right direction, then perpendicular will be upward directions. So for that reason I have drawn the perpendicular upward direction. But if you want to find out the B cross A, that means what, B vector is this one, A vector is this one, B cross A means what, you have to rotate B vector two-way vector. So B cross A, that means what? It is which direction? You are moving right to left. So if you move right to left, then perpendicular is your downward direction. So in this situation you are writing magnitude is same, no problem, magnitude is same, but direction is, I am writing n1 cap. So C is equal to A cross B if I write, and B cross A is equal to, if I write here D vector, D vector's direction will be which directions? D vector direction will be downward direction. Okay, this is the direction of the D vector. Okay, and D vector's direction is n1 cap, I mean downward vector. Now, is this commutative law hold? No. So in cross product, it will not obey the commutative principle, because A cross B is not equal to B cross A. Okay. So this is the cross product, and how you are doing the cross product. So suppose for example, if we consider the same way, A vector is equal to your A1 I cap plus A2 j cap plus A3 k cap, and B vector is equal to B1 I cap plus B2 j cap plus B3 k cap, and see, just I am writing A cross B if you want to find out. So see, this one is I cap, j cap, k cap. If you write here, first is A vector, you are writing A1, A2, A3, and in case of B vector, you are writing B1, B2, B3. So I cap will be what? See here, I cap means A2, B3. Just try to understand A2, B3 minus A3, B2. So I am writing A2, B3 minus A3, B2, right? Just it is looking like the determinants form. So A2, B3 cross multiplication, A2, B3 minus A3, B2. So same way, minus j cap. Minus j cap means what? Same things. A1, B3 minus A3, B1. Okay, plus k cap means what? K cap means A1, B2 minus A2, B1. Okay, so this is your cross product. This is your cross product. Okay, cross product rule is this one. Okay, understood? So the vector products is over. Okay, next we are considering what the applications of the vector product. Okay, so up to this, thank you.